now we'll start with MATLAB built-in function for interpolation. We have a function called interp1, and it's outstanding tool for interpolation for state of data. The general syntax is interp1 x, y, and xi. Remember, here it looks different than forecast in Excel. In Excel we put the required value in the beginning. Here we put it in at the end. So the syntax is different, and it's very important to differentiate between MATLAB and Excel. So we here put x, y, and then we put the value you want to interpolate. If you write the interp1 in this one, it will use linear interpolation to estimate the x1. Suppose that you want to use more complicated interpolation method. So then we can interp1 x, y, xi, then between single quote we put the name of method. What's name of method? According the method you want to find. For example, if you want to make linear, put linear between parentheses, so it's the default. If you cancelled or didn't put linear, so it will be calculated similar one. Then you can find it, use the nearest neighbor interpolation or next neighbor interpolation. You can also use previous neighbor interpolation, or spline, or cubic interpolation, or cubic. Okay, also there are different methods here. You can use any of them according to your information, according to your set of data. If you know already distribution of data, so you can select the best way that give you the correct interpolation value you want. So let's just to differentiate between the one. Okay, so we put x, we put y, okay, and then we just we create a linear interp1 x, y, and then x it's 11.8, so it give me 65.09. Then we want to interpolate to the nearest, so we put near equal interpolation x, y, 11.5 nearest, so it give me 65.10. Spline, okay, equal interp1 x, y, 11.8 spline, so the value become 66.98. okay. So now, if you want to see how the data or how to function works, okay, we can create vector from minimum to maximum of x and interpolate it, then plot it as a line. To do this, so we put x, y, okay, we put the values, then we create xn. You can it's length space from 0 to 55. We put from 0 here to 55. Okay, also we make xn. Okay, this is for the line you want. Okay, interpolate x and y. Okay, and for each xn. Okay, so now we will create xn. We'll interpolate each one of xn. Okay, then plot xy as circular or circle xy, and also plot x not xn interpolation and yn interpolation. So it will give me this shape, this one for the interpolation and this one for the original value. So this is the shape of interpolation. Okay, now let's repeat the same for the other interpolations to see the difference of shape. Okay, so this is for the nearest interpolation. As you can see, the values are different here. Okay, for spline interpolation, it gives me very strange value. In the spline, they cancel all the minimum values and also consider them values here. Okay, also for the next interpolation, previous interpolation. So as you already now see, so now we have a different method, and each one has its own figure or its own way to plot the interpolation and to find the results.